Let's talk about how climate change specifically affects forest ecosystems. So far, we've been talking about the mechanisms of climate change, but let's now focus on specific changes that are going to be of interest to us as forest ecologists. In the western US and in many places like it, which are dominantly arid ecosystems, our lives, our well-being, our economic well-being is closely tied to the function of our mountain forests. In California, these hold a very substantial portion of our annual water supply. These ranges are high and close to the ocean, and they can intercept a lot of moisture. In addition to reservoir of water, these mountain ranges, and this is not just true in Sierra Nevada, support other kinds of economic activity, recreation, and so forth. And that situation is true when you look across the world. For example, in the Alps, this is near Chamonix, France, the mountains themselves, the water that they hold, the unique culture that it develops in these areas are all valued, important, and furthermore are changing. A loss of snowpack and a general reduction of precipitation is changing our mountain forests. In particular, it's leading to increases in tree mortality. What does the future hold for our mountain forests? It looks like, at a minimum, we're on the hook for a lot of change. We expect that a tree mortality as a phenomenon has been increasing across the globe over the last several decades, and is expected to increase with continued drying of the climate. One of the more important and active areas of research in forest ecology is to try to anticipate when and where these kinds of tree mortality events will occur. One of our key problems is not just that the climate is drying, but periods of drought are also more likely to be associated with higher temperatures. That is, drought is getting hotter. Both of those factors can lead to a shift from stable ecosystems to conditions that are not sustainable. And this is the general description of this, where forest structure, forest composition is stable under current climate, but increases in temperature and drier climate is likely to cause mortality. Now we can see the evidence for this when we look across the globe, and given that we don't know how much change is going to happen, we don't know exactly where it's going to happen, and those are important questions, but we can be fairly certain that it is coming, and that it is coming in many places. And that gives us something, a basis, something to work with. And that's what this great analysis from Millar and Stevenson had pointed out, that in many cases where we know that we're exceeding the thresholds for sustaining a particular community, and we know that we're on the hook for mortality and potentially compositional changes, where we can anticipate those, we can lessen the impacts. So as I said, there is a clear role for management here, and it's important for us to look for solutions that will soften the blow. So what kind of changes do we anticipate? Many in North American forests, and this is probably going to occur for all North American forests to some degree or another. Our arid forests are especially vulnerable. We have, because plants, the ability of trees to defend themselves is often influenced by the environment, we can expect increased rate of insect and pathogen growth, that's the individual organisms themselves, and at least for a period of time, increases in their impacts. So that's true. Climate will affect both exotic insects like this one, which is an East Coast exotic forest pest called hemlock woolly adelgid, as well as our native pests and pathogens such as bark beetle. In general, water stress reduces plants' capacity to defend themselves. That's a very broad generalization, but it is essentially one that you can apply in many different places. And in particular, there is concern that for many pests, changes in winter temperatures, increases in winter temperatures can lead to range expansions. And there's been some great work recently, a number of different studies that work to anticipate these interactions better. But let's talk about what we expect in terms of changes in vegetation. There have been some other attempts to model landscape vegetation change. And in the West, which is, as I say, this arid ecosystem, arid region of the world where forests are very important for local economies, sustain the natural resource dynamics of the people who live there, the natural resource needs of the people who live there. And what we should anticipate throughout the West and in places like it in the world is a loss of snowpack. And regrettably, that is likely to lead to a disproportionate loss of mountain forests. How will we can anticipate some of the changes here, and that is an increase in arid land vegetation, such as the Great Basin sagebrush type ecosystems. So that's what we anticipate here, and there's some attempts at the landscape scale to try to model these dynamics and anticipate where and to what extent we can when they will occur. These changes are happening in California as well. It's not just the rest of the West, and they're happening throughout the West in all kinds of different ecosystems, including ones as different as riparian forests in the arid Southwest, and in the arid woody plant communities in the Southwest as well, such as the Sonoran Desert, which you're seeing here. And the last point that I'll make is the tree mortality itself is not always a problem. There are many beneficial aspects of tree mortality. Trees dying, creating structure and habitat. The problem is when we have too many trees dying at once, and it overwhelms our capacity to manage that, and when it diminishes the natural resources we rely on.